So next is design patterns. So throughout the design process, okay, a software engineer should look for every opportunity to reuse. Okay, this is what you need to understand in this particular lecture. Reuse existing design patterns when they meet needs of the design. When what does this mean? When they meet needs of the design. So you need not use everything that exists prior. Uh, okay, but they should meet the needs of the design, whatever that is asked by the customer or stakeholder, rather than creating a new one. So here we are not trying to reinvent the wheel in short to say or in precise to say. Rather, we are trying to reuse the components that already exist. Okay, that is what your design pattern says. Fine. So not only that, so this can be termed as a reusable solution. Reusable solution to a common problem. Okay. And don't think when I say reusing the existing design pattern, just imagine that it is, it is not a finished design, okay, but a template, you can say, okay, but a template for solving specific design issues, okay. Like those templates or those patterns, they will provide you how to code, or the way you have to structure your code such that it be more scalable or flexible or efficient. So that is what design pattern will allow us. Okay. So just remember, whenever we say this reusable, so don't reinvent. So don't reinvent the wheel. Okay, this is what the main intention here. So don't reinvent the wheel. Rather, we apply the well-established solutions or the components which are readily available from the previous, and we try to make use of them whenever we feel that these are appropriate for the current project. So what are these are some common design patterns. So first one we call is a singleton pattern. Okay. So singleton pattern is nothing like this is the singleton pattern. Okay. So the singleton pattern is nothing but this will ensure that a class has only one instance and provides a global point of access to that instance. Okay. Then second one is a factory method pattern. So here we have to write this is factory method pattern. Okay. Where it will define an interface for creating the objects, but allows subclasses to alter the type of objects that will be created. And the third one is observer pattern. So in this pattern, an object will maintain a list of dependents, okay, that are notified automatically when the subject state changes. Let us try to see the example for each one. So I told you singleton pattern. So in singleton pattern, this will ensure that a class has only one instance and provides a global point of access. So now, for example, a logging class, okay, where only one instance should exist to manage logging throughout the system, right? That is an example. So factory method, so where it defines an interface for creating objects, okay. But the point to be remembered is it allows the subclasses to alter the type of objects that will be created. Okay, for example, let us say an e-commerce system which could use a factory method to create different types of payment gateways like credit card, Paytm, or something like that. So depending on whatever the user is trying to select. So then next one is observer pattern, where a object, when I say object, this is a subject I'm talking. Object maintains list of dependents. When I say dependents, these are the observers. Okay, so that are notified automatically when the subject state changes. So for example, in an email notification system, the user will subscribe to specific types of notification. For example, the customer or the user is subscribed for promotion kind of emails. And when an event occurs, all relevant users are notified with whatever the notification that they have subscribed for. Clear? So that is what observer pattern is. So these are all the common design patterns. Next, using patterns in design. Okay. So when we talk about this, the design patterns can be used throughout software design. The problem description is examined at various levels of abstraction to determine if it is amenable to one or more following types of patterns. So first one is architectural pattern. Next is design pattern. Third one is coding pattern. Okay. Next, pattern based software design. So what is this pattern based software design? Right. So pattern based software design, which leverages proven solutions, design patterns to solve common design problems in a reusable and efficient way. Okay. So in a reusable and efficient way. Design patterns are general reusable solutions to common problems that software developers face. So they are not ready to use code, but are templates or guidelines that can be adapted to fit specific needs. Just ignore this. So they are not ready to use code, but are templates or guidelines that can be adapted to fit the specific needs. Got it? Done. So as you can see, in the very first point, it is mentioned that so it's a reusable kind of way where we are trying to implement, that is to use the existing things. Okay, so when we say the pattern based software design, so here it is mentioned that it leverages the proven solutions. Okay, which means the design patterns are kind of general reusable solutions. Okay, so which are faced by the software developers. Of course, they are not ready to use code, but are templates or guidelines that can be adapted to fit the specific needs. Clear? So, in other words, to say for the same thing, a design pattern can be a repeatable solution to a commonly occurring problem. So, within a given context. Clear? Next, so types of design patterns. So first one is creational pattern, next is structural pattern, and next is behavioral pattern. So what are these things? So first, creational pattern. So these patterns deals with the object creation mechanisms, trying to create objects in a manner suitable to the solution. For example, we have seen the singleton pattern, right? So the singleton pattern, what does it do? It ensures the class will have only one instance and provides a global point of access to it, right? So that is what falls under your creational pattern. So these patterns deal with the object creation mechanisms, trying to create objects in a manner suitable to the solution. Next one is structural pattern. These patterns deal with the object composition and help simplify the structure of software systems. So example is there is a pattern called as adapter pattern where it will allows incompatible interfaces to work together by providing a wrapper that translate calls from one interface to the other. Okay, that is what a structural pattern. The adapter pattern. Here it is singleton pattern. The examples, what I'm writing are. Then it's behavioral pattern. These patterns are concerned with communication between objects, ensuring efficient interactions. So the example for this is observer pattern, as we have seen in our previous slide as well. Observer pattern, what it does, where it defines one-to-many dependency that is between the objects, which allows one object's state change to notify all the independent objects. Clear? These are types of design patterns. Benefits of pattern design. Okay. So the benefits of pattern design can be the whole pattern works on the principle of reusability, right? So that is what is the biggest benefit we get from this, where the design patterns provide reusable solutions. That means the developers use the established methods and avoid the redundant development work. So in turn, what happens when we make these kind of implementations is we try to reduce the development time, and also we ensures that there is a consistency in the design what we are developing. Clear? Applying design patterns in software development, right? So where we, choosing the right design pattern is always essential in achieving the desired outcome. Okay, because there can be many patterns which are available. Okay, there can be many patterns that are available, but it is quite important, like what exactly or what kind of right choice that we make from that. Okay, so then uh, when we talk about applying design pattern in software development, we are talking that choosing the right pattern is most important, right? Since there are a lot of patterns which are available, okay, choosing the right pattern matters a lot. So while selecting this particular, a particular design pattern, so then what kind of things that has to be taken care? So I'll tell you. First one is the problem context. Okay. Second one would be the requirements. Third one will be the future scalability. Okay. So as I told you, applying the design pattern in software development, so the developers find it most or more useful to select the right right pattern from a pool of existing patterns. But which one is the right one? Makes the key of all the software development, right? So for those selecting the right pattern, we have to consider this. That is the problem context and the requirements, future scalability. So when I say problem context, it is like what problem are you trying to solve? And when I say requirements, so what systems, functional and non-functional requirements are required for your project? Then the future scalability is, so will your pattern, whatever you have selected, will work well when the while the system grows or evolves, or when the time comes to scale up the existing system. So whether it works or not. So these three things has to be looked while you select it. Okay. Thank you, students. Hope you understood.